Ladies and gentlemen, I welcome you to the first sort of business session of the conference. We are going to hear a very important lecture, the keynote address by Professor Om Prakash Shah. Professor Om Prakash Shah received his B.Tech Honours degree in Naval Architecture from IIT Kharagpur in 1980, MSc in Ship Production Technology from the University of Strathclyde, Scotland, 1982, and PhD in Engineering from IIT Kharagpur in 1996. Presently, he is a Professor Emeritus in the Department of Ocean Engineering and Naval Architecture. He has been head of the department, Dean of Continuing Education, and has had a vast range of interests from CAD/CAM, high performance vehicles, ship design, and ship production. He was also awarded the Best Teacher Award by IIT Kharagpur and is indeed a very distinguished and highly eminently qualified person to give us this keynote address. I now request Professor O.B. Shah to deliver the keynote address. Thank you.
Thank you, Professor Gokan, for the kind words. Thank you, Frost and Utkal Chamber of Commerce and Industries Limited for giving me this opportunity to give an address on hybrid electric propulsion for greenhouse gas mitigation, opportunities and challenges. Speaking in front of a distinguished gathering, which includes two of my teachers who have taught me naval architecture, one now as President Frost and the other as chief guest, is a difficult task for me also. But I am happy that I sent my paper to Professor Gokan first. Please have a look at it, and if you think it is not properly assembled or not coherent, please let me know. He has okayed the paper, and therefore I think I am confident to speak on this particular subject. I am not going to dwell much on inland and coastal transport to start with. Professor Gokan has rightly said this sad state of affairs as far as the development of both coastal and inland transport is concerned in the country. However, I have been members of various bodies by ministry, Inland Water Development Council, where when the bureaucrats and the ministers go and present, it gives a completely different picture. It's up to you to judge which is correct. The last time I went, where the minister, cabinet minister and the secretary was there, I was told that there has been an increase in, of course everything is in the past 1 decade, of 1,723% in inland transportation. I still can't figure out how it has happened, but that is how the government statistics goes. My paper is purely on what I have learned in the last 1 year, and especially while working with Gardiner shipbuilders on development of a 150 passenger all-electric ferry. The content of my talk will be introduction, why we need it, why there is a need for electrification, then the marine electric systems, the key enabling technologies, and under this you will see it is the electric propulsion, where is a motor comes into picture, the DC based power system versus the AC based power system, which one do we choose? Now here I am stepping into the domain of electrical engineering. This is certain things I have learnt over the last 1 year, and I'm sure if there are electrical engineers here will question me on this. Then we have energy storage and batteries. Very briefly on shore charging and fuel cells. How these batteries can be applied. When I say batteries, I mean any external source of power. It could be battery, it could be fuel cells. How can be applied on board ships? Then what are the different modes of operation of hybrid electric drive vessels? And then the design consideration for both all electric and hybrid electric vessels. And finally, I'll sum it up with a case study, or it's not just a case study, it's an actual live project which has been successfully built, an all-electric catamaran ferry by GRAC, in which IIT Kharagpur was heavily associated, and how we had gone about designing and putting it into practice, and then the conclusion. There has been a lot of talk by the International Maritime Organization, and in COP26, Paris Agreement was told that we should limit our temperature rise well below 2 degrees and considering the pre-industrialization base level to less than 1.5 degrees. This is the general requirement, and the marine industry also, though they are comparatively less polluter, but then 80% of the cargo, as you know, in volume is still carried by means of waterborne transportation. And therefore, it is also important that the Maritime Organization makes its contribution in this particular regard. What has been decided in the recent MEPC, that is the Marine Environmental Pollution Committee, 8081, that we have to cut down our emissions, considering a base year of 2008, of 40% in CO2 emissions. By the time we come to around 2050, there is a problem here. By the time we come to 2050, our emissions should be cut down by nearly 70%. And by the turn of the century, we should achieve near zero CO2 emission as far as ships are concerned. Now, this is a big challenge. And to achieve this, in the last MEPC 82, which just concluded a month back, I happen to be one of the members in that committee from the Indian side. There are two elements out there, one technical element and an economic element. The technical element looks at the fuel, what fuel you are using, and this particular fuel has to be defined in terms of grams per greenhouse gas emission, that is grams per equivalent CO2 emission divided by megajoules of power. Now this is called GFI intensity, or greenhouse gas fuel intensity, and this will be slowly brought down by a particular curve year after year. So certain ships will be above this and certain ships will be below this. How they will trade by what we call pooling or surplus trading or remedial units trading, that is being discussed. Some agreement has been reached, but not the final one. The more contentious part is the economic element, where there is a levy to be put on every CO2 that you emit. So you are being penalized twice. Once by the GFI standard, which is being slowly brought down every year, like you have seen in cars and other industry, and the economic measure, which is basically the amount of CO2 you emit and you pay that amount of money. The European countries are very much in favor of levy, but the developing countries are very skeptical because it may have a huge impact on their economy. So this is something which is still being debated, but I'm sure by MEPC 83, something will come out of this. And once it comes out, this country has to follow that. Now, this is from IMO I have taken. Use of energy on board ships, as we know, can be for various purposes. And we can try to reduce this energy on board the ships, which is as given by IMO, by various means. We can reduce it as a naval architect in this area, as Professor Gokan will rightly say, also in this area we can go. A marine engineer will do a basically a proper fleet management and can reduce the CO2 emissions in these areas. This is what IMO says. So this is the part where naval architects have been thoroughly involved. And this is the part where many engineers come into picture. But I can tell you, whatever advances you do, whatever thing you do, there is a limit to which you can go up to. You at the end of the day, you have to, I keep telling people, you have to satisfy your Archimedes principle and you have to obey your Newton's laws of motion. Okay? No text, you cannot achieve things outside these two laws. Okay? Right? Nothing extraterrestrial will come and help you out. So, but as you can see, there is a huge potential in this area, that is alternative fuel, because they form a major part of, as we can see, the greenhouse gas emission. If I can stop this, okay, then most of my problems is taken care of. And this can only come through means of alternative fuel. However, there is a problem now with alternative fuel. And the problem with alternative fuel, which is being discussed, is where are we looking at? We have to now look at the fuel extracted from the source and taken onto the ship and used. So if you look at a fossil fuel, okay, you have two divisions there, and this is a very common terminology now. We call it well, as you can see here, and to the wake of the ship. But it is divided into two parts. The extraction part, which then goes to the double bottom tank of the ship, and then the burning part, which is called tank to wake. Now, we were, the Indian delegation was trying to put most of the thing on tank to wake, saying that well to wake is not our, well to tank is not our responsibility, but that has not been agreed by the IMO. IMO says fuel has to be assessed from well to wake. In other words, the CO2 emitted in this region also becomes very, very important. And we will talk of ammonia. But how are we producing ammonia? If we are producing ammonia by means of normal, what you call LNG production or something, you have a huge problem coming up. In fact, it will be worse than the fossil fuel if you look at the whole cycle, what we call life cycle analysis. And this I have taken from the NKK document if you look at it. If you look at this carefully, you will see that even HFO, for example, it has a very small contribution from well to tank. In other words, it doesn't consume much, it doesn't emit much CO2. It's most of the CO2 emission is from tank to wake, inside the ship. But you come here. If you come here and look at this particular option, I think it is hydrogen or even ammonia, there is no tank to wake emission. But to produce that ammonia, if you are using normal coal, thermal power or LNG gas, then there is a huge amount that you are consuming. The same is true with methanol. And all these you can see is much higher than the CO2 emission if you consider well to wake. However, if you can produce ammonia using renewable energy like solar, wind, or solar, wind and other renewable energy, tidal wave form of energy, then only you can bring this down. And this is something which is still a long way to go. What people have discussed in the recent MEPC is that there can be a bridging in the sense, before this technology comes up, there can be some sort of a bridging, and that bridging can take place with the help of biofuels. Now, if you look at biofuels, which is mainly being advocated predominantly by India and Brazil, okay, you can use biofuels, and this can readily go into the normal fuel. As you can see, the different blends of biofuels we have. But here also there is a problem. It is not that simple. If you compare this with a normal fossil fuel, you can see here, it's about 100, the CO2 emission, if you put it on this particular base. Whereas if you look at the biofuel, yes, there is a sequestration going on here. But then to get the biofuel, to bring it to the place and burn it, and you are using some farmland which is being used for food production for this biofuel generation. So that also you have to take into account. So you have some negative, but at the end of the day, you only land up around 80, 85 compared to 98 or 100 out here. There is a saving, I do agree. But don't think that I have used biofuel and therefore I have achieved a lot. But this is being looked at right now as some sort of a thing. By the time better and better or newer technology come, but I feel that they must come very fast. Okay. Otherwise, all these so-called target that IMO has set and the COP26 have set will never be met. Therefore, I now come to the inland vessel part, and there is a need for electrification. And this, for inland vessels, especially for ferries, cargo ships, coastal and inland, harbor tugs, and I have missed fishing vessels also in this, there is a way out by using electricity as a source of power. This is one way out, I said. For a big ship, this is not the case. Okay. If you can electrify your ship, as you have seen in cars, then you can achieve straight away absolute zero emission. Of course, the question will first arise, how is this electricity being produced? If it is being produced by thermal source, then you have an issue. All that you are doing is you are making your city clean, but somewhere else it is getting polluted. Okay. The fixed electrical distribution system, we have learnt a lot from cars, is the common point for any energy converter and modular propulsion. What electrical system will offer, as we'll go along this lecture, we'll see, it offers as a modular propulsion and energy storage system. And this is very crucial. It gives us the option to upgrade and retrofit. And tomorrow, if the same electricity can come from e-source or can come from hydrogen fuel cells, you can gladly accept it and go ahead with this. You can still use your internal combustion engine, but in future you can replace it by e-fuels, and therefore you can achieve your target. And therefore, as the technology develops, this becomes easier. We'll also see that vessels which have variable loading conditions, you will save nearly 30 to 50% of your fuel consumption if you go for a hybrid electrification. Now let us look at battery operated ships. When I say battery, means battery as one of the source of power. It is not that battery is the only source of power. You can see this is from recent statistics a year back. You have a large number of cars and passengers ferries. They are picking up and all the slopes are going up. Fishing vessels have also played a prominent part, and you also have offshore supply vessels. In this context also, let me ask you, along with IMU and Gardiner Shipbuilders and IRS, we have submitted a proposal to Ministry to look into if a fishing vessel can be electrified. There will be a cost involved, initial cost, but we think in the long run it will be beneficial both to our coastal waters and also to meet our environmental obligations. So there is a sharp increase, as you can see. I have not numbered the other type of vessels which slowly increasing on this. Now, how do we define a marine hybrid? I use the word hybrid here. An electrical propulsion system can be defined as any propulsion system employing electrical motor to power some or all of the vessel's propulsion. It is not necessary the electrical power is providing all the power. So it could be in case of power takeoff or power taken. You can have diesel electric with battery and with shore charging. You can have battery electric vessels, as we'll see later on. You can have fuel cells electric vessels. And you can also have renewable generation on board, which could be solar, which also could be now, which is very much catching up, is the wind power as a means of recuperating power on the vessel itself. And the Europeans have taken a big lead in this area. Now, if you try to analyze the electric vehicles, as you see on the road also, you have these Tata and Citroen vessels which are pure electric, as we call it. Then you will see a lot of vessels which are not pure electric, but they call it hybrid electric. And then there are these plug-in hybrids, which is basically not having their own source for power generation, but plugging into which most electric cars are. What you see is that over the years, it is the hybrid electric that has now dominated the scene. And it is this area that we'll be looking into. I'm not saying that they are not important. All of them have increased. But if we take it as a percentage of 100, it is the hybrid electric that has now become more than 50 to 60% of all electric vehicles. And why is it so? We should look into it. What are the main benefits of going electric over conventional diesel drive based systems? This, we have to understand this. It is not that we didn't have diesel electric submarines, but what is happening in hybrid vessels we should look at. There will be a reduction in fuel consumption without any doubt, which will result in the lower greenhouse gas emission. There is going to be a reduction in maintenance cost. There will be improved redundancy and uptime or reduced downtime. I think this Baltimore ship that capsized, if it was hybrid electric, it wouldn't have happened because the downtime or uptime is very much reduced in such vessels. Okay, it will have an improved performance, less noise, no smoke, and the most important is it is easier to integrate different types of equipment. Important for naval architecture and the shipyard is that you can install them in a modular manner, which is very good, and any modular construction is always good from design and construction point of view. There are three types of electrical configuration, and I showed you the variations that are taking place. There is pure electric, where only batteries as a source of power with shore charging system. Then you have hybrid, which is the one that I'll be mainly discussing, in combination with or another onboard source of energy. And then you have the plug-in hybrid with a dedicated charging system in combination with another source of power on board the ship. Let us look at pure electric, and this is more or less what we did in Garden Reach case. Only batteries are there, used as an onboard source of energy, like you see for the Tata Nexon cars. They are capable of being operated only on isolated short routes. You don't go on long routes with pure, what you call electric car, vehicles. Distance to the base. Wherever you are, you can reach your base, will decide the energy storage system capacity on board. And that becomes an important weight and an important cost also. Small passenger ferries operating on short routes. I personally think we should go for pure electric. And within sight of land and support, we should definitely go for pure electric rather than increase the cost for going hybrid electric. RoPax ferries, inland waterways, short distances, port vessels and ships operating in microeconomy with very high power density, a higher population density is ideally suited for pure electric. Just recently, a month back, I read a report. I think in Norway, we have reached a tipping point now. There are more pure electric cars compared to other types of vehicles. And in most Scandinavian countries, capitals, I think from 2025, inside the city limits, they will not even allow hybrid vehicles to enter the as a mode of private transport, not to be there. What we have here is very simple. We have an AC source of power. Sorry about this. You will have a rectifier. You can have solar modules. We'll come to the charging control. We'll go to the batteries. And then you have, again, a back to what we call an inverter, AC converter. And the motor is always a AC electric motor with a variable frequency drive. It not only reduces harmonics, it provides a much better speed control of for the propeller also. Okay, this is the pure electric configuration. Then we come to the hybrid electric. I'm not going to read all this. The things are very similar in nature. But what is important is in hybrid electric, you can see that you can deal with the intermittent loads very well, as you will see there. Okay. The engines, as you are aware of, they can be run at a constant RPM, where their fuel consumption is the least. And any external higher load or lower load can be then dealt with accordingly. The lower load, you can charge it, and the higher load, you can use your battery backup. So this is how the hybrid electric becomes very, very popular. And later on, you can use your hybrid electric systems also. Let us look at this hybrid electric in slightly more details. You can have these hybrid electric, as you have learnt in, we can have a series hybrid, you can have a parallel hybrid, or you can have a series parallel hybrid combination. Okay. As I said that in hybrid, one of the source of power is electricity, but you will have a diesel engine also to help you with the power source. So let us look at the next diagram, which will make it very clear what I meant by all these three. Let us look at series hybrid. What is important here is the green line. It is a DC bus, and I'll come to it why it is a DC bus. You have a engine, diesel alternator, AC to DC, that is a rectifier, feeding it to the DC bus. You have the battery, again DC to DC to match the frequencies. Again, I think electrical people will help me out. You can have fuel cells, you can have solar energy, and you can also have shore-based charging. Shore-based charging could be AC, bring it to DC, all onto the DC grid. From the DC grid, when you drive your motors, it is basically again DC to AC you have to convert by inverter. Same here. The loads, of course, will go for the hotel and auxiliary load. So this is a series hybrid construction. But when you need more load and when you cannot have that much of battery power source, what you can do is you can go for a parallel hybrid propulsion. All you have done in a parallel hybrid propulsion is this portion, as you can see, I have kept it same. It is not going to change. We have added an engine which goes straight to the main propulsion unit out here, which is also being provided by the diesel generator. So you can run this at a constant RPM with the minimum fuel consumption, and additional loads can always be balanced by the other modes of operation. So this is the black line is basically the mechanical line, and the green lines are basically the so-called electric lines out here. Okay. Now, the same thing if you go for series parallel, you have a situation like this. What is the difference in a series parallel is, this is again the same with one small difference. From the engine, you have a shaft-driven alternator, which also powers to the DC bus. Okay, so the main engine can go directly, can also have a power takeoff or a shaft-driven alternator, and the rest is exactly same to what I have tried to show out here. So this is what, now these are important things which a designer, naval architect must consider when he's designing his vessel. When I have always said that it can't work by saying that I just put an electric motor and put a propeller and then say I have achieved electrification. That's not how it should be. And then you have the plug-in hybrid, which basically also helps us, as you have seen, to reduce our onboard energy storage. And but then you need to have better charging points or more frequent charging points, which you can see.